Now we'll see statements of second law of thermodynamics. The first one is the clausius statement. Now, which says that it is impossible for a heat engine working in a cyclic process to transfer the heat from a body at lower temperature to a body at higher temperature without using any external work. So we know that the heat flow will take place from body at higher temperature to body at lower temperature. But if you want to transfer the heat from body at lower temperature to the body at higher temperature, then you have to supply some external work as we are doing in case of refrigerator and heat pump. Now, Kelvin Planck statement says that it is impossible to construct a heat engine which, while operating in a cyclic process, produces no other effect except to extract heat from a single reservoir and do equivalent amount of work. So what it says that it is impossible to convert 100% of heat into 100% of equivalent amount of work. So these are the two statements. So let us see once again. So Clausius statement says that if you want to transfer the heat from body at lower temperature to the body at higher temperature, then you must supply the work. And Kelvin Planck statement says that it is not possible for any engine operating in a cyclic process or operating in a cycle to convert equivalent amount of heat into equivalent amount of work. So 100% conversion of heat into work is not possible. Now let us see with the help of the figures how it will be understood. So for example, if you want to understand Kelvin Planck statement, then what does it says that whatever the heat is supplied from the source, the heat will get, and if that heat is supplied to the heat engine, it will convert this heat into equivalent amount of work. So this will satisfy the first law. But actually what happens, out of certain amount of the heat that is supplied, some part of the heat is always rejected. So work will be equal to heat supplied minus heat rejected. So this will satisfy first and second law. Similarly, if you want to understand this from the heat pump, then heat sinks, it will absorb the heat from the heat sink, then it will reject the equivalent amount of the heat to the heat source. So that is the first law. Whereas in case of the second law, it says that it will absorb the heat from the sink provided some work is supplied to the system, then and only then it is possible to absorb the heat from the sink and reject it to the heat source. And W is equal to heat rejected minus heat abstracted. Now, Carnot engine, Carnot heat pump, and Carnot refrigerator. This efficiency, coefficient of performance, and coefficient of performance for the refrigerator and heat pump. These equations we will derive afterwards. First, we have to just remember this equation. That is, efficiency of Carnot engine is 1 minus T2 upon T1, where T1 is the higher temperature in Kelvin and T2 is the lower temperature in Kelvin. Similarly, coefficient of performance is T1 upon T1 minus T2, and coefficient of refrigerator is T2 upon T1 minus T2. So here it is higher temperature divided by temperature difference. Here it is lower temperature divided by temperature difference. And here in this case, if you cross multiply this T1 to this one, it will be temperature difference divided by higher temperature.